please everyone leave now.
Hello everyone, can you hear me?
Daddy, leave, hey? Leave नहीं कर सकते.
Dear students, leave the meeting. We will leave the next time.
Hello everyone. Thank you for your patience. Can you hear my voice?
Yes, sir.
Okay.
Yes.
Thank you. Could
Yes,
you
sir.
please mute your audio? Thanks. Okay. So the session started a little late than when it was supposed to start, but anyway, we will be welcoming all of you to the seminar on Maths Olympiad for Bose this is the Bose Math Olympiad seminar for class 1 to 4. So if you are not in class 1 to 4, you can attend the next session. The next session starts from 7 p.m. IST. Okay? So you can attend that. So we were discussing some of the main ideas from Mathematics Olympiad in the last two classes. And one of the major themes that we sort of came across is often known as pattern recognition. So what you do is you see a bunch of things. You see a bunch of things and you recognize a pattern in that seemingly unrelated set of things. You recognize a pattern in that seemingly unrelated set of things. So maybe I can just unmute myself here. Okay. Hello, Adish. So let me do one thing. Okay, so this one is unmuted. And what I can do is I can sort of, yeah. So yeah, all of you can hear me now inside the class as well. You can put it in the chat actually, if you can hear me. Okay. So yeah. Yeah. Okay. So I think people can hear me now. Maybe I can start the video as well. Right. Great. Thank you. So as I was saying, that the main idea is recognizing patterns, and patterns are almost everywhere in mathematics. If you look at a bunch of numbers and if you think that, well, there is something common between each of those numbers, then you sort of found a pattern. If you look at a bunch of shapes and you see that there is some commonality between those shapes, you say, okay, there is a pattern. That's great. Okay. So this is what we are looking at. We are hunting for patterns. So let me write that. We are hunting for patterns. And one of the patterns we will be studying today is related to shapes. It is related to shapes. So this is the problem. You can think about it like this: that suppose we have uh, 3 points on this plane, So we have A, B, and C, 3 points on this plane. And what we do is we look at these 3 points and we try to find a point inside the triangle. Let's call that point P inside the triangle, such that if I join AP, if I join BP, and if I join CP, all of these things are equal in length. So if you measure the length of PA, if you measure the length of PB, and if you measure the length of PC, all of these 3 lengths are equal. So PA is equal to PB is equal to PC. You want to find such a point. You want to find such a point such that it's equidistant from each of these vertices A, B, and C. So maybe you have a friend. Maybe you have a friend. So maybe, okay, so this is your friend 1. This is your friend 2. And this is your friend 3. So you have 3 friends. You have 3 friends. And you want to make a home. You want to make a home that is equally distant from your 3 friends' home, so that you can meet them all at once. You can meet them all at once. So the main question is, how do we find the point P? So how to find this point P? This is the central question of today's session. Okay, so if we start this problem with 2 points, say B and C, answer would be very easy. Why? If you look at this, suppose we have 2 points instead of 3 points. If we have 2 points, say we have 2 points B and C, can anyone tell me how to find a point that is equidistant from both B and C? So find a point that is equally distant from B and C. How would you go about it? How would you find a point whose distance from B and C are equal? Think about it, and let's see if anyone can respond in either in Skype or this is being broadcasted in Facebook, this is being broadcasted in YouTube, and also in Zoom. So if let's see if anyone can respond to that. So if we have 2 points B and C, how would you find a third point, let's say P, which is equally distant from B and C, which is equally distant from B and C? So this is how you should actually think about it. There should be an array of points, a collection of points which will satisfy this particular relationship. So for example, if we have a point A1 which is equidistant from B and C, there will be another point A2 which is also equidistant from B and C, There is another point A3 which is equidistant from B and C, and so on. What I would ask you to do is to imagine all of these points together. Imagine all of these points coming together. Who are these people speaking in the chat? Okay. Excellent. Varshika, you are right. Excellent. Kritika is also correct. You're right. Very nice. Very good. We should definitely be joining these points. You're right. We definitely should be joining these points. And we are, Varshika is also correct. We can just take the midpoint of BC. Very nice. So if we join these B and C, this particular segment, we can just join B and C, this particular segment. Then we can just take the midpoint of that segment. Let's call that M. If we join B and C, and if we just take the midpoint of B and C, then that point would definitely work. Very nice. Sharan is also correct. So in fact, this is this other way of thinking about midpoint. What is the meaning of the word midpoint? The word midpoint means it's a point, it is a point equally distant from B and C. So suppose you are standing at the point M, the midpoint, and you want to walk to B, or if you want to walk to C, in either of the cases, you will be covering the same distance. Okay. Now the point is, the fantastic point is this, that there are more than one point which works. Of course, the midpoint works. The midpoint is equally distant from B and C. The midpoint is equally distant from B and C. But there are other points which also will do this thing. So here we go. Let me draw it one more time. So if we have 2 points, 2 dots B and C, if you have 2 points B and C, and if you mark the midpoint M, the point that is in the middle of B and C, then that point obviously works. That point is equally distant from both B and C. So that's true. M is equal distance away from B and C. But there are many other points which also works. There are several other points which also works. So there is a point here. There is another point here. All of these points are equally distant from B and C. All of these points are equally distant from B and C. Right. So I want you to think about all these points. I want you to imagine all of these points together. Can you make your mind imagine all of these points together? If you think about all of these points together, let me draw them in red. Let's say this is A1, this is A2, this is A3, this is A4, this is A5, and then you have M. So if you are Abdul Manan and Vinita, I see what you're saying. Please be patient. This is a Olympiad level class. So if you are unable to understand, please be patient. This is a seminar style class. So I won't be able to respond directly inside the session. Try to draw the picture in your notebook. You have to work a little bit to understand what's going on. Okay. Okay. Now the question is, how would you add up all of these red points and how will they look like? If you add all these red points, or rather join all the red dots, how will the picture look like? So if you join this with all of these red dots, thank you, Oishik, you're right. This is a straight line. Excellent. It is one straight line that passes through the midpoint of this. Yes. CBSC, who is this Abdul Manan? What is wrong with this guy? I'll just, okay, Abdul, you can leave the session. You're just wasting time. Okay. What is CBSC here? I don't know what you're talking about. Okay, so now the question is, instead of B and C 2 points, if you want 3 points, thank you, Shurjadeep, that's right. Selena, you are correct. And Redmi, this is also right. Exactly. Very nice. Nirmal Kumar, you are correct. It looks like a line. Now the question is, instead of having 2 points B and C, if you have 3 points, then what happens? So now the challenge is a little bit more interesting here. So let me just move this a little bit. We have 3 points, A, B, and C. Can you find a point in the plane? Can you find a point somewhere in the plane which is equally distant from ABC? So PA is equal to PB is equal to PC. So if you take a scale, if you take a ruler, and if you join PA, and if you join PB, and if you join PC, all of these 3 lengths will be equal. Is it possible that there are more than 1 points which will do the trick? Maybe there is another point Q which also does the trick. Maybe there is another point Q such that QA is equal to QB is equal to QC. Maybe that's possible. Maybe there are more than 1 points which work. So Juma Devnath is kind of, okay, Sandeep Baldwa is also saying that you can sort of average out the points, which are very good, very nice answer. It's a nice way to think about it, at least. Juma Devnath, you are right. That's indeed the circumcenter, but we're not going to use that word here. The question is, how would you find that point? If there is a point like that, how would you find that point? So I'll tell you how to imagine and find the point, which is equally distant from A, B, and C. So maybe I can write that. Our goal is this. Find a point which is equally distant from A, B, C. And if possible, find more than 1 points like that. If possible, find more than 1 points like that. I don't know whether there are more than 1 points which do this thing. So how do you go about it? Well, the strategy is this. This is the trick. You take two at a time. You take two at a time. So handle 2 points at a time. So how do you do that? Okay, so you take 2 points B and C. So maybe I can write that. So if you have 2 points B and C, and I'll just focus on B and C for the moment. I'll just focus on B and C for the moment, and then I'll go to A and B. All right. So let's go to B and C. And remember, there was this line that passed through the midpoint of BC. There was a line like this that passed through the midpoint of BC, a line like this, such that all the points on the line were equally distant from B and C. So the great thing about this red line, the great thing about it is all of them are equally distant from B and C, which is great. But then you can also deal separately with AC. You can deal separately with AC. What does that mean? Well, what you can do is you can find all the points which are equally distant from A and C. So find all the points which are equally distant from A and C. So it will be something like this. So these green points are all equally distant from B and C. These green points are all equally distant from B and C. Okay. So do you see that the green and the red line meets at a point? Do all of you see that? The green and the red line meets at a point. So here we go. Here is the point right here in blue, right? This particular point, this is the magic point. This is the magic point. Why? Because this point is equally distant from B, from C, and from A. So the major takeaway from this session, is that you take two at a time, you find all the points that work, and then you look into the intersection of those points. Okay. All right. So I'll give you the link to find additional resources related to this Maths Olympiad, and you can also find other interesting courses there. This Olympiad is in the month of June. Is in the month of July. So you should be able to attend it. So maybe I can put the link here. Let me just put the link here on YouTube as well. So it's chinta.com/Bose. You should go to that link and you can find more information about the contest. And we will be stopping out the session here. Thank you.